All right, my friends. So we're back and we're going to go into our next lesson here in Unit 3. All right, we're on page 120 in your workbook. All right, and we're going to start working with more specific types of angles. All right, and we're going to identify some special angle relationships here. All right, and you can see that this is really the first half of standard 7.1 to 7.4. I can identify special angle pairs. All right, so to get to that, what I would like you to do is try the opener here. So go ahead and pause the video, do what it says, and then we'll flip it back on and see how you did. All right, so now notice what it says here. If I cut a straight angle with a ray and gave one angle measure, all right, how would you find it? So if we think about the first one here, here's my straight angle. All right, and we cut it with a ray. So it just means add a ray somewhere in here. And it tells us that now we create this angle that is 25 degrees. Well, going back to the prior lesson, we know that a straight angle has 180 degrees. All right, so if this is 25 degrees, then that means the rest here, the second angle that we would formed here from adding a ray, would have to be 155 degrees. So hopefully that made sense to you, because we know they have to add up to be 180 degrees. All right, in a similar fashion here with 120, right? So here's my straight angle. We add a ray, right? And now we create this 120 degree angle here, all right, which means that, once again, this leftover angle over here has to be 60 degrees because we know they have to be 180 degrees. Now, part 3 here, what if I did the same thing but to a right angle instead of a straight angle? Well, the idea would pretty much be the same. And let's see if I can do this here. All right, so if we had a right angle here, correct? If we added a ray, okay, what do we know about these two angles that will be true every time? That's right, they're going to add up to be 90 degrees. Okay, now how does that lead into today? All right, so now we're going to introduce two specific terms here, complementary and supplementary. And that is talking about what two angles add up to be. So the definition of complementary, all right, is two angles, all right, whose sum is 90 degrees. All right. And once again, this would be a diagram for that, right? So they could be what we say are adjacent angles. And what adjacent angles mean, I'm just going to label this angle 1, angle 2. All right, adjacent angles mean they share the same vertex and a common ray. So we know the measure of angle 1 plus the measure of angle 2 has to equal to 90 degrees. All right, in that picture. But complementary angles don't necessarily have to be adjacent. All right, so I could have this angle here, and we'll say angle, this is 30 degrees, right? And then we're going to say we have this other angle over here, and this angle is 60 degrees. So notice these two angles are also complementary because their sum adds up to be adds up to be 90 degrees. All right, so they can be adjacent, all right, or they can be non-adjacent. All right, now same thing with supplementary. Now supplementary means we have two angles whose sum is 180 degrees. All right, so they add up to be 180 degrees. So our examples up here are perfect examples of that, correct? All right, where we had that straight angle. All right, we added a ray here. So we know angle 1 and angle 2 here, right? Measure of angle 1 plus the measure of angle 2 has to equal to 180 degrees. And these would be adjacent, all right, angles. Once again, they share the vertex, they share a common ray. All right. Now, once again, they could also be non-adjacent. So I could have, all right, this angle right here, and let's say that's 100 degrees. All right, and then I could have another angle here. Whoops. Maybe make it a little bit, and let's make that 80 degrees here. All right, so those two add up to be 180 degrees as well. All right, so now, vertical angles. We're going to see this in just a moment, but I'm going to go ahead and give you the definition now. So vertical angles, all right, two angles who share a vertex and, all right, have opposite rays. All right, so two angles who share a vertex and have opposite rays. And so what does that mean? So if I draw this angle right here, okay, all right, notice it has to share the same vertex and they have to have opposite rays. So this would go this way, and then this would be the opposite ray here. So notice angle 1 and angle 2 would be vertical, as would be 3, and 4. So angle 1 and angle 2 are vertical, and angle 3 and angle 4 are vertical. And what you're going to learn is that we always get vertical angles when two lines intersect, all right, at a point. And we get two pairs there. So 1 and 2 are vertical, and 3 and 4 are vertical as well. All right, so there's some basic definitions for you. So let's flip the page, all right, and let's look at page 121. All right, now this is really just what we did. I'm going to go ahead and skip that for now. All right, so notice when we think about complementary, all right, C comes before S and 90 comes before 180 degrees, right? So just to help you remember, complementary is 90, supplementary is 180 degrees. All right, okay, so now, all right, here's what I want you to do. I'm going to give you a few minutes, all right, to do 1 through 5 here on the bottom of page 121 here. All right, so I want you to follow the directions, see what type of relationships you see or think exist, and then we'll go through them and see what you came up with. So go ahead and pause that video and we'll see how you did in just a moment. Okay, so draw two intersecting lines. All right, so here's one line. Here is a second line. And just to talk about these, I'm going to go ahead and label these 1, 2, 3, and 4 here. All right, just so we can look at them. So now, notice, all right, look at the two angles across the intersection from each other. So now that's getting into vertical angles, right? So 2 and 4 and 1 and 3. What relationship does it seem like they have? All right, now you obviously don't have another group member here, but when you look at these, don't they look the same, right? So angle 2 and 4 look like they might have the same measure, and 1 and 3 look like they have the same measure. And I drew mine almost at a right angle, but even if I went a little flatter here and did something like this, right? All right, so 1, 2, 3, 4, right? It definitely looks like 1 and 3 are the same, and 2 and 4 are the same. All right, and that's really what we are wanting you to get to, is that vertical angles are congruent. They will have the same measure. So if angle 1 is 80 degrees, angle 3 would also be 80 degrees. If angle 2 is 100 degrees, angle 4 would be 100 degrees. All right, so that was one of the things that we wanted you to see here. All right, now, if we look at problem 4 here, look at the two angles next to each other on the intersection. What relation does it seem like they have? So when you look at 1 and 2, 2 and 3, 3 and 4, 1 and 4, any of those angles that are adjacent, all right, to each other, once again, they share a vertex and a ray, what does it look like they have in common? And I hope you said that they are supplementary. Use that new vocabulary word, right? So we know 1 and 2 are supplementary because they make up this straight angle here. Same for 2 and 3. They make up this straight angle. 3 and 4 make up this straight angle. 1 and 4 make up that, all right, straight angle. All right, so hopefully you said they are supplementary. Okay, now we actually have a word for this. We call these a linear pair. All right, and we're going to see that in just a second. But we call these a linear pair because it's two angles that make up a straight angle, which is a line. Okay, so there is that. So now let's go ahead and flip over. All right, then I'm just going to go through our terms here at the top, and then that will wrap it up for our video for today. So if we have vertical angles here, and we're going to have linear pairs. All right. Now, what we want to understand is that we get vertical angles and linear pairs every time two lines intersect. Okay, every time. So once again, I'm just going to go around